In this problem, we're going to use a right triangle and the Pythagorean theorem to find our missing trig ratios. When we set a Pythagorean theorem, make sure that you have the 9 as your c in the a squared plus b squared equals c squared equation. The hypotenuse always has to be c squared. So when I solve my equation, I had b squared equals 65. And that cannot be simplified, so I'm going to just call it the square root of 65, and I'm going to label my triangle with it right here. All right, SOHCAHTOA. So let's start with cosine, because that's part of our SOHCAHTOA pattern. It's adjacent over hypotenuse. It's always a good idea to label your triangle, especially if you're getting stuff mixed up. The opposite side has to be across from your angle theta, and adjacent means touching, so it has to be touching your angle. And the hypotenuse is always the hypotenuse. So the cosine of theta is adjacent over hypotenuse, which is 4/9, and we're done. The next one we're going to look at is the secant. Secant and cosine are reciprocal functions. There's no other work to do here other than just flip cosine over 9/4. The cotangent is the reciprocal of our tangent function. So instead of opposite over adjacent, I'm going to do adjacent over opposite. Most trigonometry teachers do not want to see a radical in the denominator of a fraction. So this answer would be considered unsimplified. I'm going to fix it up by rationalizing the denominator. That means multiply the top and the bottom by square root of 65. The reason why is because the denominator will just be 65, and now there's no more square root down there. The numerator is 4 times the square root of 65, and that's okay. As long as there's no square root in the denominator, we're good to go. That's my final answer.